In this video, we're going to learn how to solve a system of linear equations using matrices or row operations. We will start by writing our system of equations as an augmented matrix. So I'll set up brackets 11, -3, and 11. Notice that this represents our first equation, where the first column contains the coefficients for our variable x. The second column contains our coefficients for variable y. Then we have a vertical line which separates my variable containing terms from my constant. We'll do the same for the second equation. 33 3 and 37, which represents 33x plus 3y equals 37. We'll solve the system by performing row operations so that we end up with a matrix in row echelon form. In row echelon form, our 0 rows are contained at the bottom of the matrix. The lead entry in any non-zero row is 1. To get our matrix into row echelon form, we need to know what row operations are allowed. There are 3 types of row operations that we can use. We can switch rows, we can perform row operation, or row multiplication rather, where we take a constant and multiply it through each equation. And we can also perform row addition, where we add 2 rows together. So let's get started solving this system of linear equations. For our first row operation, let's multiply row 1 by the fraction 1 over 11. In other words, 1/11 times row 1, and we're going to store that in row 1. So 1/11 times 11 equals 1. -3 times 1/11 equals -3/11. And 11/11 equals 1. And then we'll rewrite our values for the second equation, which we've applied no changes to yet. For our next step, let's perform the row operation -33 times row 1 plus row 2, and we'll store that in row 2. So our next step is -33 R1 plus R2, and we're storing that in R2. So we'll sketch a new matrix. In the top we have 1, -3/11, and 1. And to find our new values for row 2, we're going to multiply -33 by row 1. So -33 times 1 gives us -33. -33 times -3/11 equals +9. And -33 times 1 equals -33. We're going to add this to row 2, which is 33, 3, and 37. And this gives us a result of 0, 12, +4. This is what we'll store in row 2 of our new matrix. So far, our row operations have led us to have a leading 1 in row 1 and a 0 leading row 2. This is the result that we're looking for. So let's continue to use our row operations until our matrix is in row echelon form. Our next step is going to be to multiply row 2 by the fraction 1/12 and store our result in row 2. So 1/12, row 2, and row 2. We'll set up our new matrix. Row 1 is not going to change. We'll multiply 1/12 by row 2. 1/12 times 0 equals 0. 1/12 times 12 equals 1. 1/12 times 4 equals 4/12, which reduces to 1/3. So we have a diagonal of 1s with a 0 below the 1 on the upper left. Our matrix is officially in row echelon form. So let's analyze this system. And use our new matrix to solve for x and y. My new system is x minus 3/11 y equals 1, and y equals 1/3. Our system has been solved for y, so I can take y equals 1/3 and substitute it for y in equation 1. So we have x minus 3/11 times 1/3 equals 1. The 3's cross cancel. X equals 1/11. X minus 1/11 equals 1. And adding 1/11 to each side will give us a result of x equals 12/11. So just to recap, we started with a system of linear equations in x and y. We wrote our system as an augmented matrix and then used row operations in order to rewrite our matrix in row echelon form. Once we had our matrix in row echelon form, we used our solution for y to substitute into equation 1 and obtain a solution for x. This concludes our example. I hope you found it helpful, and we'll see you next time.